Carter is with me. I do not have Trenton. He might be in corrections room. Okay. Yep. Bye. Okay. What I have put on these sheets. So today we're just graphing parabolas. Part of it is review from when we graphed parabolas in chapter 4. However, all of the characteristics that we had labeled on our graphic organizers, including the focus, the directrix, all of that also needs to be on your graph when you graph a parabola. I'm looking for all of the characteristics. So I included on here, I know the word length kind of got cut off by the hole punch here, but I have on here all of the characteristics that we have labeled on our sheet just for us to fill in what those are in relation to our parabolas. I meant to also include this on the assignment sheet and I didn't, but just know when you're graphing a parabola, all of this is what you should be finding and then putting onto your graph. So make sure you're finding all of the key characteristics of your graph. So if we look at number 1, we have y equals x squared plus 6x plus 4. So in order to graph a parabola, you want your equation to be in standard form. So it has to be in one of these two forms so that we know what a, h, and k are, so we can use those values to find everything else with our formulas. So we're going to have to complete the square, go through that process like we did yesterday to get the equation into standard form. Because this one already has the y by itself, I know it's going to be y equals, so I can start right away with grouping the x terms together. And in order to complete the square, we need a 1 in front of the x squared, which we already have, so there isn't anything here we need to factor out. So I'm just going to rewrite this. We have y equals x squared plus 6x plus some number that we need to find to complete the square. On the outside, we have plus 4. And then remember to keep your equation balanced. Whatever is added here is subtracted on the outside because it's the same side of the equal sign. So what number would go here, or how do we find it to complete the square?
The b over 2 and then parentheses squared.
Yes. So 6 divided by 2 squared is 3 squared, which is 9. And then I don't have anything to multiply that 9 by in front, so if I'm adding 9 here, I'm subtracting 9 at the end or on the outside to keep that balanced. Then the x squared plus 6x plus 9 gets factored. So in factored form, what would that be? What quantity squared? X plus 3, yep. And then I have 4 plus 4 minus 9 at the end, so minus 5 it would be. So this is the standard form. And I can then identify A, H, and K. I will need all 3 values to find everything else in this problem. So what is the A value? Sierra?
Where did you get
The
the 9 from?
9 is the 6 divided by 2 squared, so your B value divided by 2 squared. What is A? A is 1. What is H? -3, and K is -5 because it's minus 5. All right, so then as we find these, some things I'll graph right away, but as we find these, we'll include them on our graph and make sure our graph is complete with all of the characteristics. So vertex, so this is where you might want your formulas. Actually, as we're looking at this too, what direction is this parabola opening? Which way is it going to open? It's going to open up. Okay, so why that's helpful to identify is then I know on my graphic organizer, all of my formulas are in this very first box. So this is the only place I need to look to find anything I need to know. Okay, so I'm going to find the vertex. Vertex is HK. So I know the vertex will be at -3, -5. And I could actually, on my graph, just plot that right away. -3, -5. Axis of symmetry is x equals h. So x equals -3. And remember, so for a parabola, it opens up, and you can see this on your graphic organizers as well. Axis of symmetry is that vertical line that goes through your vertex. And we draw that in as a dashed vertical line, so I can draw that in. And actually, before I move on to finding the focus, directrix, and the length of the latus rectum, I want to draw the parabola in. And in order to actually draw in the curve, I'm asking that you have at least 3 points. We already have 1 because we have the vertex. So we have -3, -5. But I would like you to have at least 1 point on either side of the vertex just to get a better shape for your parabola. So what number could we plug in to find another point? Somebody just pick another x value. -2. Okay, so if I substitute -2 in and really what you could do, you could substitute it into your standard form. You could substitute it back into the original if that's easier for you to substitute it into. That doesn't matter to me. But if I substitute -2, I'm going to substitute it into the standard form. I would have -2 plus 3, which is 1. 1 squared is still 1. And then 1 minus 5 is -4. So that y value would be -4. And then I don't need to plug in another point. What other point do I know is on the parabola? Yep, -4 and -4 if I reflect it over that line of symmetry. So you really only need to substitute in 1 point to really get 2. But then I can actually draw the parabola in. Make sure I said the parabola should open up. So if I'm getting a parabola by substituting in a point that's opening down or opening sideways, something's wrong. Or maybe I identified it incorrectly, but it at least makes you, or should make you kind of stop and check that what you're doing is correct. Okay, so then I know the focus is going to be a point inside of the parabola. I need to find what that point is. On your graphic organizers, the x-coordinate of the focus is h. So I know the x-coordinate is -3. The y-coordinate, I'm just going to do this off to the side. The y-coordinate, I have to evaluate k plus 1 over 4a to find the y-coordinate of the focus. And I know k and I know a, so I can substitute those values into the expression and evaluate what that would be. So it is -5 plus 1 over 4 times a is 4. So it would be -5 plus 1/4. You can, if you type that into your calculator, you can give the answer as a decimal as long as it's a terminating decimal. So this would be -5 plus 0.25. So -4.75 is what that would end up being. So then I can plot that point. And again, you should make sure the focus should be inside of the parabola. Look on your graphic organizers to see in relation to the parabola where it should be. So if your focus is ending up somewhere else, then it's incorrect. So if I graph -3 and -4.75, it's very, very close to my vertex. Much closer than what you see on your graphic organizer, but it is inside of the parabola. So that's the focus there. And then for the directrix, this has the formula from your sheet. It's the equation of a line, so it's going to be y equals some number, and it's y equals k minus 1 over 4a. So that's going to be y equals negative 5 minus 1/4, or minus 0.25. So that'll be negative 5.25. So y equals negative 5.25 would be the equation of the directrix. And again, looking at your graphic organizer, that is a horizontal line that would be underneath a parabola that opens up. And you should draw it in as dashed. I know on your graphic organizer it is a solid line underneath, but it should be a dashed line when you actually draw it in, just like the axis of symmetry is dashed. So it's very, very close to your vertex, but at the y value negative 5.25, I should have a dashed horizontal line. Okay, and then the last thing, and the lattice rectum, you don't actually have to draw in. You can. I'm not going to make you actually draw that in, but I do want you to know how to find the length of that line segment. And if I asked you where it was on a graph, to know where it is. But the length of the lattice rectum is the absolute value of 1 over a, so that's what we wrote in the margin on your graphic organizer. And since a is 1, it's the absolute value of 1 over 1, which is just 1. The absolute value of 1 is just 1. So the length of the lattice rectum would just be 1 unit. And again, you don't have to draw that in. If you did, that's fine, but you don't have to. I realize the focus is already very, very close to your vertex, and it's not a very long line segment. Okay, so what I'm seeing that you can do from this is, one, you can find all of these key pieces or key characteristics of the graph. Finding them is one thing, but then you can actually kind of put together a full graph of a parabola with all of the characteristics. So are there questions on this first example? And I'll let you know in the future in this chapter. For right now, if I just say graph a parabola or graph the equation, and it's the equation of a parabola, I'm looking for you to include all of this. Later on, if we're just graphing systems of equations and a parabola is one of them, I just need you to graph the parabola. But for right now, just graphing a parabola includes all of the key pieces to it. Okay, we're also going to go through the second one together, and this one we also need to write the equation into standard form. It's not in standard form at the moment. This one does not have a variable by itself though, so which variable are we going to get by itself first? Is it going to be y equals or x equals? X equals. We have a y squared, so I'm going to have to subtract y squared from each side first. So x equals negative y squared plus 4y minus 1. I group the y terms together, and before I can complete the square, I do have a negative 1 in front of that y squared that I'm going to have to factor out. So I would have x equals negative 1 in front, or just a negative in front. And then in parentheses, I have a positive y squared. The positive 4y is now minus 4y. And then I'm going to put a plus blank right away to complete the square. I still have a minus 1 at the end. And then minus whatever quantity gets added to the inside. So to find the value that completes the square, my b value is negative 4, so negative 4 divided by 2 squared would be negative 2 squared, which is positive 4. Now make sure though, because I do have the -1 in front, remember that the -1 and this 4 get multiplied together. So -4 and -4 is what goes in this blank then. So I am subtracting a -4, which really means I'm adding 4. So then I have x equals, I have a -1 in front, or just a negative. Y squared minus 4y plus 4. If I factor that, what quantity squared will it be? Or Corey, did you have a question? Yes. Yes, the negative, because in order to complete the square, the value in front of the variable squared has to be a positive 1. So what quantity squared would we have from factoring this? Close? Y minus 2, yep. Because of the minus 4y that's there. So a -1 times y minus 2 quantity squared, and the -1 plus 4 is a positive 3. So this is our standard form. And then let's identify A, H, and K, and then which way it's opening, just so when we are graphing, we know if we're doing things correctly. So what is the A value? -1. What's H? H is not 2. H is 3. So remember, this catches people, and it's not, well, I didn't make the formulas. It's not meant to be a trick. It just is tricky. When it's x equals, H and K have now switched places. So H is out of the parentheses, K is inside the parentheses. So H is positive 3, K is positive 2. Okay, if you have those switched, that's going to throw off your graph. And then which direction should this one be opening? To the left. Okay, so when you're looking at your graphic organizer, you should be looking at the bottom right one that we filled in. These are the formulas that we'll be using. Okay, so vertex is still HK. So vertex is 3, positive 2. I'm going to plot that right away. Axis of symmetry is now a horizontal line that goes through the vertex. The equation is y equals k. So y equals 2. So I can draw that in as a horizontal dashed line. Double check, it should still be going through your vertex. It's just horizontal, not vertical. Okay, then again, before I find focus, directrix, and the length of latus rectum, I want to get 2 other points. Now, when you make the table for these, this is opening sideways. Looking at this equation, if I set up a table, does it make sense to, well, I can still do x, y here. But does it make sense to substitute in an x value or a y value into this equation? It makes sense to put a y value in to find an x value. So substitute in a y value, and then the x value on either side. So you still need to find 1 point. We'll be able to reflect it over our axis of symmetry to find another point, but substitute in a y value. So if I have the y value 2 for my vertex, I could probably substitute in the y value 1. And so I'm putting that in for y. So I have 1 minus 2 is -1. I have to square that first. -1 squared is +1. Then I would take that positive 1 and multiply it by negative 1. So that's negative 1. And then plus 3 would be 2. So when y is 1, x is 2. So I can plot 2, 1. And if I reflect that over the axis of symmetry, what other point is on our parabola? Where would that reflect? It wouldn't, no, but it wouldn't be 4, 1. Not 3, 0. 2, 3, yes. It's going to reflect up here. That's okay. Thanks for trying. Nobody else was trying at the moment further, so thank you. Okay, so remember, if a parabola, you can look at your sheet. If a parabola opens to the left or to the right, these are not functions. These do not pass the vertical line test. So you're graphing a parabola, it's not a function. So when you make a table, you're going to see repeated x values. That's okay. It's not a function. So I'm going to turn my sheet, though, to actually graph this. And we said it should be opening left, which it is. So if I were graphing this and somehow now it's opening down instead of left, I know I did something wrong. Okay, these are a little strange. Now I can find the focus and directrix, graph those, and then find the length of that lattice rectum. So the focus, so here to find the x-coordinate, I have to evaluate h plus 1 over 4a for the x-coordinate. My h value is 3 plus 1 over 4 times negative 1, so that'd be 1 over negative 4 or negative 1/4. So I'm really taking 3 minus 1/4 to get my x-coordinate. And 3 minus 0.25 would be 2.75 for the x-coordinate. The y-coordinate of the focus is just k, and that's 2. And again, it should be inside the opening of the parabola. If it's somewhere else, it's wrong. So if I were to graph 2.75 and then 2, it is, again, really, really close to the vertex, but it is in the right place. It's inside of the parabola. I will say the more narrow your parabola is, the closer the focus will be to your vertex. If your parabola is really wide, then your focus is farther away from the vertex. The directrix is a line for a parabola that opens to the left. It is a vertical line, and it'll be on the right side of the parabola. Again, draw it in dashed. The formula to find it, it's x equals, so x equals h minus 1 over 4a. So that'll be 3 minus negative 1/4, so really 3 plus 1/4. And 3 plus 0.25 is 3.25, so x equals 3.25 would be the equation of the directrix. So if I find 3.25, again, it's really close to your vertex, but it is on the right side, and it is a dashed vertical line. And then for the length of the lattice rectum, which again you don't have to draw in, absolute value of 1 over a would be the absolute value of 1 over negative 1. The absolute value of negative 1 is 1. So the lattice rectum again is 1 unit long. Okay, questions on that one? Okay, so from here, is everyone, or are some people are still writing? I would like to help for number 3, getting the equation into standard form. There's just something a little different about it. But I want to help you get the equation in standard form, identify AHK, but I want you then to graph it. So without my help, you find all of the characteristics and graph it. Okay, am I okay to flip this over? Okay, so for example 3, first of all, what variable do we have to get by itself to get this into standard form? X. Notice though there are 2 terms with X. So what I want to do is get all the X's on one side and then everything else on the other side. I am going to keep the X positive, I'm going to subtract 3X from each side. But that means I'm going to have an X still on the right side, so I'm also going to want to subtract 5 from each side. So I would have negative y squared and then minus 5 on the other side. And I'm just going to flip this around. So I have x equals negative y squared minus 5. This is actually already in standard form now. Okay, because you don't have another term that just has y to the first power. So this is actually standard form. What is the a value? Negative 1. What is h? H is negative 5 because, again, it's x equals, so this minus 5 is actually h. K is 0 because if you just have y squared, that is like y minus 0 squared. So k is 0. And then which way is this one opening? Which way? Left. Okay, so there's the information to help get you started. I'd like you to find the key pieces of information, make the graph, make sure you're able to find these and make the graph without me leading you through it. As I come around to check, I will pass out the assignment as well that has some extra practice with it. But if you have questions, please ask when I'm walking around.